All right, to really understand fractions, what we're going to have to start out doing is understanding factors. And so factors are the numbers, whole numbers, that multiply to form another whole number. So we can think of like the number 63 as being the result of 7 times 9. And these are factors of 63. Now, every number has 1 as a factor. So we tend not to talk about, I could put 1 times 7 times 9 in here. What we're looking for is how to break numbers down into their factors. And there are certain numbers that only have, and they're called primes, 1 in themselves as factors. So primes only have 1 and themselves as factors. We exclude 1 from this, so 1 is not a prime. 1 kind of holds a special place in our numbers. And so, for example, 2 is a prime, and 2 is the only even prime. Then we have 3, 5, 7. 9 isn't prime because 9 can be made up of 3 times 3. So our next one is 11, 13, 17, 19, 23, 29, 31, and so on. These are prime numbers that they can only be written as a multiple of themselves in 1. And what this lets us do is break numbers down into primes. And so we're going to call this process prime factorization. So for example, going back to 63, we're going to make what's called a factor tree. And it's made up of 7 times 9, but 9 is also made of 3 times 3. And so this outer branch of the tree we made are the prime factors. And we could write 63 as 3 times 3 times 7, or 3 squared times 7. And all numbers, all composite numbers, can be written uniquely as a combination of prime factors. And this will help us in understanding prime or fractions. Because what we'll want to do is use these to help us write fractions in simple forms. So this unique ability for us to write numbers as primes will help us with fractions. So for example, the number 16 can be broken, well, there's a couple different ways to divide this. I'll go 8 by 2. Well, 8 can be divided by 4 by 2, and 4 can be 2 times 2. And 2 is prime, so these are the prime factors. And there's 1, 2, 3, 4 of them. So we could write 16 as 2 to the 4th. And that's the prime factorization of 16. Again, I don't write the ones in here, your book does, because 1 is given. All right. Let's look at how this helps us with fractions. So, since fractions are divisions, we want to write what's called the simplest form. And to find the simplest form of a fraction, we want to get any shared factors out of the way. And so we say we put it in the lowest terms. So let's look at an example. 10 divided by 42, or 10 42nds, right? You remember, division and fractions kind of are the same. Well, if we expand these out as the prime factors of 10 are 2 and 5. Now 42 is 6 times 7, and 6 is 2 times 3. So it's 2 times 3 times 7. Well, we can think of these multiplications as coming from separate numbers, and I'll put the 1 over 7 here. I can think of these fractions coming from different parts. And notice the 2 over 2 would be 1, which leaves us with 5/21. And this is the simplest way of writing 10 42nds. We say it's in the lowest terms. The general idea is you write the prime factors, and anytime one appears over top of the other, they become 1, or we say they cancel out. And it's because they've turned into the number 1 by existing like that. So let's look at another one. 9/27. Well, 9 is 3 times 3, and 27 is 3 times 3 times 3. Right? 9 times 3. So we have these 3's, and that leaves us, remember, there's that hidden 1 written up here, 1/3. And so 9/27 in its simplest form is 1/3. And let's look at it one more. 8/36. So 8, as we said earlier, was 2 times 2 times 2. And 36, well, 36 is 6 times 6, which is 2 times 3, and 2 times 3. So we have 2 times 2 times 3 times 3. And so that 2 cancels that 2 cancels that 2, and I get 2/9. And so that is how we write these in the simplest form. All right. Let's look at a couple more examples. Oops, I keep hitting the wrong button here. Sorry about that. You're probably just hearing me in the background as I'm switching computer windows. So I'm looking at, I want to look at one more example, which is 35/75. Now, if you notice, figuring out the factors are really important to these. Now 35 is 5 times 7, which are both prime. But 75 is, whoops, factor tree here. Well, as I'm trying to figure out what 75 is, I know it's 3 times 25, because I think of money in quarters. And then 25 is 5 times 5. So that outer bit are my prime factors. 3 times 5 times 5. And that'll make 7/15. And so 7/15 is the same as 35/75, just written in simple forms. Simplest form. And the simplest form helps us kind of work with these better. Now, we can look at fractions as being equal. We can look to see if two fractions are equal. And the book does a nice way of showing this. It talks about what we're going to call cross products, which will come up a lot when we start using ratios in equations. But let's look at an example of a cross product. So we want to know if 6/24 is equal, and we'll put a question mark to it. We want to see if it's equal to 2/8. And what we do with a cross product is we kind of look at this number multiplying this number, and this number multiplying this number. So what I do is I go in this direction. 8 times 6. 8 times 6 is 48. And 24 times 2 is 48. And so these fractions are equivalent or equal. We could find the same thing out if we put them both in simplest form. So 6 is 2 times 3. 24, and its factor tree is 6 times 4, 2 times 3, 2 times 2. So it's 2 times 2, 2 times 2 times 2 times 3. And then in 2/8, well, that's 1 times 2 upstairs, and 2 times 2 times 2. Remember, we looked for all those 2's. So in this case, the 3 and the 3 cancel. One of the 2's and one of the 2's cancel. Remember, there's that hidden 1 there. I'll keep pointing that out. 1/4. And these cancel. There's a hidden 1 here. 1/4. So they're also equal if we look at simplest form. And that's a good test of, are these fractions equal? And let's look at another one. 2/5 equals 4/11. Or does 2/5 equal 4/11? So we want to say, does 2/5, question marks, we're not sure, equal 4/11? Well, I can't really simplify this, and I can't simplify this. That should be giving me a hint that they're not equal because they're not simplifying. So they might already be in lowest form, but let's do the multiplication. 11 times 2 is 22, and 5 times 4 is 20. And so 22 does not equal 20, and thus 2/5 does not equal 4/11. And so we have a couple different ways of looking at how fractions could be equal. One of the things the book does is look at distance and fractions, and we want to talk about using distance on it. Let me clear my blackboard here, and we'll use the example here. So we get this idea that 1 mile is equal to 5,280 feet. And what we want to know is how many miles is 2,640 feet. And so what the book says is you take this, which is how many feet in a mile, and you divide it into this to make a fraction. You go 2,640 feet is 5,000 as compared to 5,280 feet. Well, one of the things we can note that can help us factor big fractions like this is both of these numbers could be thinking multiplying by 10. Because if I divide both of these by 10, right, I can factor out the 10. And I know these will cancel. So I get 264, 528. And now I can either do factor trees or I can grab things that they all have in common. So let's see. I'm going to look to see if they're divisible by 4. So let's see. 4 goes into that. 1, 3, yeah. So what I did was I checked, is this divisible by 4? 4 goes in there. Whoops. 6. 6. 4 times 6 is 24. Write the 24, subtract. So 4 goes into 264 66 times. So I can write the upstairs as 4 times 66. And I can write the downstairs, well, is it divisible by 4? That would help. So 4 goes in there once, 3 times, and twice. So 132 times 4. 4's cancel. I'm left with 66 over 132. Now, there's a couple different ways we can keep going with this. Sometimes canceling fractions take a while, but I kind of notice that 66 times 2 is 132. So I could write this as 66 over 2 times 66, or 1/2. And so 2,640 feet is equal to 1/2 of a mile. And we'll look at more ways to think about this as we progress on how distance relates to ratios and fractions. We really want to make the idea that we can talk about partial units as we build up the way we're going to measure. All right, that's section 2. See you in section 3.